So today we're talking about strings. So if you've programmed before, it's one of the first things you come across are strings. And so let's play with them a little bit in Python. So what is a string? It helps to define them before we use them. Yeah. Yeah, it's a sequence of characters. So it's a bunch of characters in some specific order. And the way you define them in Python, well, there's actually three ways. So you can define a string by double quoting it. So there's a string. You can assign strings to variables. So now if I look at S, there it is. You can define a string by single quoting it. Let's say S2. And you get the same effect. So you can use double quotes or single quotes. Anybody know why you would want to use one or the other? Yep. Yeah. So one nice thing about being able to use one or the other is, right, the quotes start and end the string, and so it can be a little bit tricky if you have quotes inside your string. So for example, that's fine. We can look at that. It's as you expect. Whereas that would be a little bit difficult if you did this, or if you try to do this with single quotes, then you get an error because you started the string here and it ends at the second single quote, and then there's some trailing garbage that Python doesn't understand. It gives you a syntax error. So if you have single quotes inside your string, you can use double quotes, and if you have double quotes, you can use single quotes. So for example, so that's sort of one convenient method for that. There's also a third way to define strings, and you don't do it too often, but well, there's a special application of these things, and that's actually to use triple quotes. So anybody know what those are for? Any Python people? Yep. Yeah. So the typical thing that you use these for, so you use them for multi-line strings, and there's just a convention in Python that you use these things for comments. In particular, at the beginning of a function, you'll put something like one of these strings to mark off to describe what this function does. And I don't know, you return. I don't know. So it's a good practice for any function you define to include at least a one-line comment here that describes what the function does. And if the function is a little more complicated, then you can use a multi-line comment, which is just a string, to give more details. And so there's, for example, a long-winded comment for this, this function. A one-liner would be a better, in this case it's such a simple function, you just one line saying what it does. The code explains how the conversion is done. And I'd like you to put these, even for assignment 1, for the questions you do, I'd like you to put at least one-liners in there, these one-line comments saying what each function does. And with respect to that, someone asked a question about whether their code needed to look nice or be nicely formatted to get full marks. And the answer is yes. You should always write code that looks nice and is nicely formatted, and you choose good names for variables and parameters and functions and so on. It's really, that's sort of a minimum standard for any code that you write. Should look nice. It doesn't take any longer to write nicely formatted code than it does to write poorly formatted code. Yeah?
Did you start recording?
Yes, I did. Thanks. Okay. What else? So now we know how to define strings in 3 different ways. The triple quotes, if you want to make a, let's say, you can do it that way. And then you get this string with multiple lines in it. So if you want a string that goes across several lines and actually includes the new lines, then you use these triple quotes. And you see when we display this, we're not printing it, we're displaying it in the interpreter. There's these funny characters in here at the end of each line, \n and \n. So this indicates that this thing has a new line in it. So I want to highlight a little bit the difference between printing and displaying a string. So here's the string S6. We're just displaying it in the interpreter. We can print it using the print function. And there, notice that a couple of things happens. You don't see the quotes because they're not really part of the sequence of characters that makes up the string. They're just used to show you that it's a string. And these new lines here, they actually get converted into actual new lines, so that these lines appear on separate lines. You don't just see this special code that says there is a new line. It actually puts a new line there. And there's actually a lot of these special codes that you see inside of strings, both when you display them and you can also use them inside. So let's see another example. So here I press after the word tab, I press the tab key, which gives you a tab character which is displayed in some funny way. And notice that in this string, when you display this string, it appears as a \t inside the string. If I print this string, then the tab character gets expanded the way you expect it to. And it's kind of weird to have tab characters appearing in your code, so another way to do this is just to say So you can also use these things when you're defining strings. You can use these codes. They're called escape codes. And it's basically usually one character with a \t before it. \t for tab, \n for new line, There's also a \r, and let's see. So does anybody know what R stands for? Carriage return. Anybody know what happens when you print this string? What's that? No, not exactly. So this \n for new line and \r for carriage return go back to the days of really old printers that printed one line of text at a time. And so n for new line is pretty clear what happens. It means that the print head moves down one line. What do you think \r does? Yep.
It goes back to the top of the line and erases it and goes over it.
Yeah, so it goes back to the start of it moves the print head to the start of the line. And, well, for printers, that meant that you could go over and overwrite text that was there. Of course, that means you're double striking it. But on things like terminals, you get results like this. So this prints A, and then moves the cursor to the start of the line, prints B and moves the cursor to the start of the line, prints C and moves the cursor to the start of the line, and then prints D. And of course, the only letter that's left at the end is the D. And you could change this to AX, and then do the same thing. So what will you see then? DX. So printed AX, moved to the start of the line, printed B, moved to the start of the line, printed C, moved to the start of the line, and printed D. So that first character keeps getting overwritten, but the X never got overwritten. So you can do a little bit of, and this doesn't work on every terminal, you can do sort of a little, using these carriage returns, you can do, it's not exactly animations, but things like counters and stuff that count up, or down, or whatever you want them to do. What else? Other handy thing. So what do you do then? So we said if you have a string that has some double quotes inside of it, then you could use single quotes. And if you have a string that it has single quotes inside of it, you can use double quotes. But what if you have both single and double quotes? Anybody see a way around that? Yeah?
Use triple quotes?
You could use triple quotes. Let's see how that works. So that works. Any other ways? Yeah. So backslash is another way to get around this. So I'll use a single quoted string, and where I want to put a single quote, I put a backslash in front of it. And sort of the rule of thumb is if you're having problems, if there's some special character or some character that's interfering, in this case it's quotes, this single quote here would be a problem because this is a single quoted string. Usually you can get the behavior you want just by putting a backslash in front of it. And that's a general rule of thumb, not just for Python, but for other languages that have strings, because it's a common problem, right? When you say a string is defined by putting some stuff around it, then, you always run into the problem of what about if that stuff appears inside of it? So you can use a backslash to hide that, and when you print it, that backslash single quote just appears as a single quote. Okay. Something else you like to do, or you can do to make strings, is you can define them this way. But Python also has a method called raw input. And it can be tricky to use. So a few things to notice here. Raw input is a method that's going to return a string, so I'll assign it to this variable called name. And it takes a string as an argument, and that string is basically a prompt or something to print just before it pauses and waits for the user to type something. And if you want to set these things up to look nicely, you usually leave a space at the end of this string. Otherwise, it looks kind of weird. Otherwise, the cursor would be glued right to the colon here, which is not what we're used to. And so I'll say enter Pat Moran. And now what's name? It's the string Pat Moran. Okay. So this is something from the assignment. I think at least 1 or 2 questions ask you to write an application that asks the user for some information. We'll use raw input for that to get the user to enter a string. Okay, so if I remember correctly, the assignment asks you at some point to write a little application that asks somebody their name and maybe their height and their weight. So we've seen now how you can ask someone their name. How about their height? Just like that? No. Okay, why not? Yeah, so if we look at height now, the height is what I entered, 74, but again, this is where the details matter, because this is not the same thing as saying height is 74. If I look at that variable now, this is the string that has the character 7 and the character 4. This is the integer 74. So there's a difference there between those two things. Anybody know how to convert between those two? Yep.
You can either just do input and then enter your height, or you could just like int.
Well, so what does input do? Yeah, I'm not a big fan of input because you don't know what you're getting back when you.
Yeah. Or you could just int height, like int brackets.
Yeah. So something you can do in Python, and which you end up doing a lot, is what's called a type conversion. So if I say height is equal to the string 74, there it is, I can convert that into a different kind of variable if I want to, and by just writing int, saying now I want this to be an integer, int height, and this will take height and do its best to convert it to an integer. So this really gives me then the integer 74. Probably that's not what I want, because somebody using this application will do something like enter their height, saying, they're sort of vain, and they'll say their height is 58 and a quarter, 58.25 inches, because that 0.25 is important to them. And so int is probably not what you want for that, so you can also ask for it as a float. then you won't have any problems with fractional parts. So anybody see any obvious questions now? Yep.
So like for the assignments, are we going to have to assume that the person testing is not meant doesn't just put in a string where we ask for a
For the first assignment, we will we'll let that go. So we'll assume that anybody who enters when you ask them for a number, that they'll enter a number, maybe float. It could be a float. So we'll let that slide. But very soon we'll see how to handle that and how you should recover for it. That'll be next week. Okay, so for the first assignment only, it's okay if your application doesn't work because somebody did something like this. So you ask them for their height in inches, and they write something like 74. So if you look at their height, it's 74, and you might want to convert that now to a float, and you get this error. So the error is fairly, the error message is fairly informative. It says, could not convert string to float. We asked to convert this string called height. We asked to convert it to a float, and it even tells you what the string was that it was trying to convert. Okay. And you can run into other problems like that. So if I say something like int 456.7, then I run into a problem there as well, because this conversion to an int won't actually won't handle the whole string. It can handle the 456 part, but you'll lose the 0.7. And rather than just quietly do that without any warnings or errors, it tells you, look, there's a problem here. Fix your code so that you can handle this kind of input, or at least tell the user that that they have to change their format. Okay. And of course, these value conversions, these types conversions, you can do them in different ways. So, for example, you can go in the other direction and take a string like or take an integer like 5,467 and ask to convert it to a string. Oh, str, yeah. Ask to convert it to a string, and you get a string. So just to remind you, the types we now know about are int for integers, float for these things that are numbers but not integers, and we also have str, which is short for string. Okay. So questions so far? It's all easy. You can all, yep. I am recording the lecture, yes. Yes?
Kind of one question. So the difference between integers and floating points has the actual decimal on the end of the
Sorry, the difference between integers and floating points?
Floating points have the decimals added on into the actual terminal window, right?
Okay, so the question is, what's the difference between integers and floating points? Well, so the superficial difference is that floating points have a decimal in them. So when you display them, you'll see this decimal. But there's a much deeper difference in that they're represented differently. So integers are represented in a way that they always, when you do calculations with them, you always get this exact correct value. Floating points, when you do calculations with them, you get a value that's correct up to a few decimal places. If the numbers get really big, then you lose some of those decimal places. So there's a lack of precision associated with floating point arithmetic that you don't have with integers. And we saw that when we said, what is 400, well, let's say 2.0 to the power 200. This says it's 1.6 something times 10 to the power 60, when in reality it's actually this number here. So notice there's some, these things agree for a while, this 1.6, but actually there's already a loss. Well, the rounding happens right there. So this thing, which is 2, 7, 5, 5, and so on, gets rounded to a 3 here. So if integers work for you, great, use those. If not, if you have to use floating point, use that. But be aware that there can be problems with rounding. Any other questions? So there's no dumb questions. In a class this size, if you're thinking of something or there's something you don't understand, there's a good chance there's a constant fraction of the class also doesn't understand it. So there'll be another 20 people or so. Yeah.
I've read somewhere that floating points have different calculation based on Windows or Linux.
They should all be using the IEEE standards for floating point calculations. So you shouldn't get different results. Now you will get different results. This was a question on the forums. Your results on the assignment for assignment testing may be slightly different than the sample output that was given in the example for the assignment, but that's probably just because when I converted floats to, or when I converted, kilograms to pounds, I used just 2.2 because I was too lazy to look up a more precise thing. The true conversion factor is 2.20 something something something. And so if you use something a bit more precise, you'll get a slightly different answer. But that has nothing to do with Windows or Linux. Yep.
Earlier when you did the round trip to the height, right?
Yep.
After you put in that function, you turn that into an integer, and then you print that. That's the right way to do it. So that you don't get a string.
Well, so here we read height as a string, and so let's say there. And now if you want it to be an integer, you would say int height. But for what you're doing, there's no reason not to go with a float, because that will make the program continue to work if somebody puts in that their height, they're 74.5 inches tall. So that would be a better choice to go to float straight away. In particular, because the next thing you're going to do is a BMI calculation that's going to use floating point arithmetic anyway. Yep. You'll have to speak up a little bit. Yes? So that's just an indication that this number here, it's an integer, but it's a sort of special kind of integer. It's a long integer. So it's not represented in the usual way that integers are represented. It had to go to some special kind of representation that could handle a number that's this big. So typically, if your number is bigger than 2 to the power 32 or so, it'll have to go to this long representation. And this is just a way of showing you that in the same way so this is a way of showing you this because you're using it at the terminal. It thinks you're a programmer and you want to know everything about what's happening here. So, when it displays a string, it puts quotes around it. When it displays an int, it doesn't put quotes around it. And when it displays a long integer, it puts this L to tell you that. But if you just print this thing, it won't put that L there. So there you go. Yeah.
Can you scroll through the things that you've previously typed? What are you pressing?
Just the up arrow. Does that work on all systems? Anybody have that not work for them? Yeah. So up arrow, down arrow takes you back in your history for the current invocation of the Python interpreter. Okay. Good. Now we'll get into some slightly advanced stuff. So let's write a simple application. So a really dumb cash register that allows you to do nothing fancier than read two prices from the user, and it adds them together and prints the result. So let's say price A, and so B equals so there's, I claim, a really simple cash register. Is this a cash register that even does what it's supposed to do? So shall we test it? So price A, let's say $5.99, price B, $1.99. And what's the result going to be? $5.99, $1.99. So anybody see what happened there? Yep. Yeah, so it read these things as strings, and then it added them together. So here A is a string, which is the characters 5.99. B is the string 1.99. And then the result is A plus B. And it turns out that strings, you can add them together. And when you add together two strings, A and B, what you get is the string A followed by the characters in A followed by the characters in B. So really what we did was $5.99 plus $1.99, and the result we got is this string, which is this sequence of characters that you get by putting these things together. And that's not what we wanted. What we wanted really was to read not a string, but I guess it's going to be a float. And so whatever raw input returns, we can convert it to a float. So notice I'm just taking a shortcut here. Calling float on raw input is no different than assigning raw input to A and then converting A to a float after the fact. So let's try this again. $5.99, $1.99, $7.98. So that seems to be correct. So other things you can do with strings, just a couple of the most common ones. You can also ask their length. So S2, S1. Oh, we're not in there anymore. S1 equals you can ask for the length of a string, and it's particularly common sometimes to ask if the length is 0. So what's the answer here? False. So that's a common kind of thing that you ask when you have a loop that says, well, cash register, for example, a typical would be you keep entering prices until you've entered them all, and then you just press enter once. In that case, what you've entered is an empty string, a string of length 0, and that would somehow indicate that you're done entering prices. The cash register should add them up. We'll see how to do that kind of thing next class. Okay, so questions now? Yep. The difference between return and print. There's a big difference between return and print. So print does what it says. It prints something on the screen. So for example, I can print here and say I could have returned the result, but then it wouldn't necessarily be printed. Okay, so this is a subtle distinction, and if I remember correctly, last year a lot of people in assignment 1, maybe not a lot, but a significant number, wrote code that instead of returning, printed the result, and it looks kind of the same when you test it in the interpreter, but it has a very different meaning, and we'll see what exactly it is, what the difference is. So run cache register 1 and 2. No. 1, 2 adds up to 3, so that prints the result. Now, if I say x is equal to cache register, so 1, 2, prints 3, but now what's x equal to? X is equal to nothing. It's defined as nothing. None. So that's because cache register doesn't return any value. It just happens to print some values. And so printing, in most applications or in most code, 99% of functions will return values because they compute something and return it, and a very small portion of the code, which is responsible for things like the user interface, will actually print things. Yep.
So when is a parameter in a function is used return if it's going to do something else?
It depends what you're asked to do. So it's not whether there's a parameter or not. It's just, if the question says write a function that returns this, then you should definitely return. And if the question says write a function that prompts the user for their age and weight and so on, and then prints out their body mass index, then use print. Yeah. Yeah.
So for the cache register code that you did, why didn't you just say return? Why didn't you print?
No particular reason other than the fact that the cache register is already somehow an interactive application because it's printing these prompts saying enter price A and enter, and people type, and enter price B and people type. So it maybe kind of makes sense that it should just finish the job and print the result in a nice way as well, and print the result in as well. So the clue on the assignment is whether the question asks you to return something or to print something or write an application. You almost always want to return a result. Okay, so we've seen now 3 kinds of strings. We've seen that there are some tricky characters that you can put into a string that are not so easy to enter. So for example, we've seen strings like this. So tricky character, the new line character is tricky because it takes you to a new line, so that will somehow break code. But you can encode it in a string with this \n. Similarly, tabs you can encode with a \t. Single quotes and double quotes, you can / those. Any other character that looks like it could be difficult to encode? Yeah, so the / itself, and there you just use the rule of thumb. There's a character that looks tricky to encode, So to encode it, I'll put a backslash in front of it. So there you get, that's how you put a backslash inside of a string. What if you want 2 backslashes in a row? Yeah, you just do that twice. Okay. So with these escape sequences, you can specify any string this way without, there's nothing that's forbidden anymore. But there is a whole other class of, they're not really escape sequences, but there's a way of putting stuff and formatting strings, which is really handy, and goes back historically probably 40 years to the first, at least to the first C compilers, and or C libraries, I guess, and that's printf formatting. So how many of you have used printfs before? Okay, so so let's say I have a situation where I have, x is 42, and now I want to make a string that looks like this string s here, but where x is, I want it to have the characters 42. So we know a solution for that. Anybody want to give it to me? Yep. Before we learn that, so we already know one way to get that done. Yep. No percents yet. Yeah, you can break up the string. So we know that we can add 2 strings together, and that gives me their concatenation. And we know that we can convert numbers to strings. So one way to do this is to define s as I want to put the number. So that's a string. And then I add x to it, convert it to a string. So that's one string plus another string. And then I add a third string onto the end. So I want to put the number plus the string representation of x plus into this string. And that gives me this string with 42 in it. So one issue with that is, so what is one issue with this? It's lame, yeah. It's kind of awkward. Already, just to do that fairly simple thing, we had to go, the code got too long. So we'd like maybe a more convenient and fancier way of doing this. And there is a mechanism in Python and many other languages called printf formatting. And it works like this. So you specify the string that you want, and you put a few placeholders in it. So in this case, the placeholder is %d, which, for historical reasons, %d stands for an integer. Means I'm going to put an integer here. And now you do something really strange. You apply the mod operator to this string. And the second argument is the value x that you want. Okay. So now if I look at s, it does this thing. So there's a lot going on here. So I made this string with this little placeholder for an integer in it. And then I said, to this string, I want to apply a special operator. It's I'll call it the printf operator. Uses the same symbol as the mod operator, but remember mod is for numbers, and this is something we're doing to a string, so there shouldn't be any confusion about what to do here. And the second argument to to this mod operator is going to be a sequence of things to use to go and fill in all these placeholders. In this case, there's only one placeholder, and so all I need is this, this value x here. So this says, take this string, look for the placeholders, and whenever you run into one, whenever you run into the first placeholder, use x to place its value there. And this particular placeholder says what you should be printing there is as an integer, %d. Slightly more sophisticated is so again, I apply the mod operator to this string and say I would like x, and I would also like 7. So we look at s. The first %d gets replaced with x. The second %d gets replaced with 7. So you really, this looks, at first this looks like some kind of magic, but really the way to think of this, Python is very uniform, and the way to think of this is you're just using this operator, this printf operator, and it's giving it 2 arguments. One is this string on the left, and on the right is this tuple, this sequence of values that it should use for the substitutions. And it's kind of ugly-ish until you get used to it, and it can be difficult to remember what all the different formats specifiers are. But once you get used to using this printf method, you'll never go back. This is one of the simplest and cleanest, most efficient ways to deal with inserting values into strings. And so we should explore it a little bit. So what do you think happens here? Yep. It'll print just 7. Let's see. Yeah. So here, this conversion of 7.5 into an integer, it silently took place, and you lost some precision there. Do you know what you would do if you didn't want that to happen? Percentage. Yeah. So %d is for printing integers. %f at least is meaningful. It's for printing floats. So if we look at that, gives you 7.5 with a whole bunch of zeros at the end. Not so nice. There are others. I think %g gives you a different version of floats, one that's a little bit cleaner. So %f somehow gives you this fixed number of decimal places regardless of whether they're useful or not. %g somehow tries to guess what the right number of decimal places is. So it's a little bit better that way. What are the other ones? Percent what? %r. So let's see. Let's play with this a bit and then see some other issues. So what happens if I put a string here? So this says for the first occurrence of a printf escape sequence, I want to replace it with the string how. Yep. Yeah, but what'll happen here? Any guesses? Yep. You get an error. So in this case, it doesn't just silently do any conversion or anything. It says, I expected a number here and I got a string. And I think we'll get the same problem if we specify a string. Even if that string looks like a number, it's still not happy with that. If you really want to put a string there, you use %s. Okay. And now we look at s. So it inserts that string there. Notice that you can't tell the difference after the fact about whether you inserted an integer or a string. It looks the same, but underneath the surface, there's different things happening. So we've seen percentage %d, percentage %g, percentage %d for integers. We've seen percentage %g, percentage %f, and g for floats. We've seen percentage %s for strings. Any others that we're missing? Yep. %i. Let's see what that is. So it looks like it's some other kind of integer. Anybody know the difference? Yep. It does. Well, integers shouldn't have decimals anyway, I guess. So what happens if I do still no decimals, but percentage %d does that also. We checked that earlier. Well, so the way to learn about something in Python, and the way in general, the way to learn about things is nowadays to use the internet. And almost always you can use Python followed by whatever it is you're interested in. The first few things you get are actually the Python documentation. So reliable stuff comes, for example, from docs.python.org, is a fairly reliable source of documentation. And so here we can see string formatting operations. And here's a list of the things you can put in here. Percentage %d for decimals, so integer decimals. O for octal. Anybody know what octal is? Yep. So it's a base 8 integer. So it's an integer where you can only have digits 0 through 7. So that's useful sometimes in computer science. There is, percentage %u tells you not to use it. It's the same as percentage %d. Hexadecimal, anybody seen these before? Yeah. So they're another representation for integers where the digits are 0 through 9 and A, B, C, D, E, F. So you have 16 different digits. And because there's A, B, C, D, E, F, there's two versions where you can get uppercase and lowercase. E is for floating point. Let's take a quick look at that. So let's change our second one to an E. And there it's really telling you, this number that I'm printing is 7.56. It will always look like that. We'll always have an integer dot something times 10 to the power 0 in this case. But if you change this to 75.56, now it's 7.556 times 10 to the power 1. So this is the scientific notation. And of course, there's two versions depending on whether you want this E here to be an uppercase or a lowercase e. Floating point, so that's floating point with a decimal place. This is another floating point format that tries to do something smart depending on exactly what your number looks like. So it does different things depending on whether you should use the exponent and tries to put the right number of decimal places. This we won't do just yet. And the percentage %s we've seen is for strings. And of course, %% gives you a % symbol in your input, right? So in percentage, in this printf formatting, percent is now a special character. If we want to print it, well, we need some way to do that, and percent does that. So put 2% in a row, that just says just print a percent. I'm just looking for the actual percent symbol. And this percentage R is somehow special because it'll print anything. So if I can use percentage R for this first argument, I see that it gives me 500, turns into 500.5. I can give it a string. It just prints a string. So percentage R, you can think of it as meaning raw. Just take whatever is given as an argument and convert it to a string and print that. If it's already a string, great. If it's not already a string, convert it and print whatever you get. Yep.
Would it make sense just to use percent R instead of worrying with the allocations, or
You can use percent R and not worry about what case it might be, but that generally shows that there's some misunderstanding in your code. I mean, usually you should know at the point where a string is formatted and you're using some variables, you as a programmer should know what kinds of variables those are. Occasionally it's useful, but actually usually only for debugging. And if you see it in production code, it tends to be a sign that somebody took a shortcut that they intended to fix later, but never did. So Python, the general rule in Python is that it tries as much as possible to be explicit. And one way of being explicit for string formatting is specifying exactly what I expect this thing to look like. So a little bit fancier. So there's these formats. Let's go back to percentage %f as an interesting one. So there's these percentage %f, percentage %d, percentage %r, a whole bunch of these things. And not only can you specify what you want, but you can also give it some clues about how you would like it formatted. So for example, for percentage %f, I can say that I would only like to see, let's say, or I would like to see exactly 9 decimal places. So to specify that, I put percentage %.9f. And then I get a string with 9 decimal places. I can say that I would like to see only 2 decimal places. And I get a string with only 2 decimal places. Yep.
Sorry, this is kind of backtracking a little bit, but when you put R, like the whatever it's called, R,
the raw.
And it has the quotation marks when you printed it out.
Did it?
Back when you was like, here's one integer and a string and another one.
Yep. So like this?
Yeah.
Yeah, okay. So actually, there's another reason not to use percentage %r. It shows you the programmer's view of this thing. So it's really the same thing that you get. What gets printed is the same thing you would see if you were working at the command prompt and said, what's the value of this variable? And if it's a string, it'll put the quotes on it to show you that it's a string. So there's another good reason not to use it for strings. It's going to put these quotes, and usually what you're trying to do is splice in some string, not put the quotes. Yeah, good catch. And I guess that also means, for example, if I use percentage %r and take 2 to the power 32 or 2 to the power 200, then it'll also put that L there, which you probably don't want to see as the output of an application. So it's really giving you the programmer's picture of the variable or the value. Okay, so you can specify the number of decimal places you would like. You can also do other things, and it's easier if we just focus on one of these. You can specify the width of the format. So I would like this string to be, let's say, 2 decimal places, and I want the number to occupy 10 spaces in this string. So you see there, it right pads the number to fill in spaces to make this thing 10 characters wide. See any difficulties there that could crop up? So there's a few. One is, well, this should be obvious. If I specify I only want 2 decimal places and there's more decimal places, well, some of them get lost in the output. And exactly how they get lost, let's see. They get lost to, at least it rounds, so 0.5653 and so on. That's a little bit closer to 0.57 than 0.56, so it rounds up in a reasonable way. What about this 10 spaces across? Is there a potential problem there? What if my number is bigger than that? So it does its best, but if the number is that big, there's nothing it can do. It doesn't really make sense to truncate the integer part of this number, so it'll just use more space than you asked it to. So when you do that kind of stuff, sort of, you can think about what that does. Now for integers, you can also specify how wide you want this thing to be, and it does the same thing. It pads it out with spaces on the left to make it exactly 10 characters wide. And so if we go back to our silly calculator, we could now maybe make it a little bit fancier and print a little bit nicer. So let's say we would like the output to look something like, whatever the answer should be. So we'd like the output maybe to print something cute like that. So like it would print on a bill maybe. So how would we do that using this %f formatting, or this printf formatting? So I'd like to print A, I'd like to print plus B, and I'd like to print C finally. Print the result, the sum of the two things. So anybody want to tell me how to get started on that? Yeah.
You could indent price A a little bit to make room for the addition sign to line up with 2 decimal points.
Okay, so let's print, the first thing we'll do is we'll print price A. And, well, the next 2 lines are going to have a plus and an equals on them, so we'll put a space in our string. But I want to be able to deal with the fact that sometimes a price may be in, $1.99, and sometimes it might be $500.99 or whatever. So I'd like things to line up. So let's use 12 spaces, be really generous. So unless our prices are in the millions of dollars, this should continue to work. And what is it that I want to put there? A. And is this the format that I want? Do I want to print an integer? No. What do I want? I want an F. Yeah, so normally you only see up to the nearest cent on a cash register output, so let's fix that at 2 decimal places. Now let's do the same for B, but instead of that little space there, we wanted the plus sign. And finally, the same for C, or the result, which is A plus B. And we want that to be equals. We left some garbage in their file. We'll want to get rid of that. Okay, $1.99 and $1.99.99. So there we get the formatting we wanted. $1.99 plus $1.99.99 is $201.98. All of these things are taking up a width of 12 characters, so there's lots of space for big numbers to mix and match, and everything lines up nicely here. And when I say that that printf formatting is, nice and compact, well, I'm not kidding, because here's another way to do this. There's the same code done in one line. If I did it right, which I didn't. There. So there's the same thing, all in one line. So so you see that's a pretty compact way to do string formatting. Combine that with new lines built into the strings, you can do this really compactly. I don't recommend you do this kind of thing, at least when you're beginning, because this is a little bit more difficult to read and debug than it would be if you just split it up into different strings. But once you get used to it, this is the kind of stuff you'll see. And feel free to have a look at these other things that you can add to these string formats. There's little flags you can use. We've seen that you can specify the width and the number of decimal places. There's lots of other stuff you can do. And there was one last thing I wanted to tell you that was I think it had to do with the assignment, but I've forgotten right now. I guess it wasn't that important. I think most of you can do just about everything on the assignment at this point. So good luck, and don't forget to submit your assignment. Yep.
Is there any way to get the next assignment ahead of time or not?
No, I don't want to do that because
Time restraints, so it wouldn't be really fair.
it causes problems.
As for lessons ahead, is there any way for that?
Lessons ahead? Not exactly, although you can go to if you go to my YouTube stream, you'll see this offering of the course from last year. Although some of the videos there are broken, so in particular the sound kicks out, but you can see the topics at least that way.
What's the channel?
It's whatever one these videos for this class are coming out on.
Thank you.
Back to our network drive, not in our lab though, is there any infrared besides just VPN?
Don't ask me.
You don't know?
I don't use any of that stuff. Talk to the people who run the network.
Okay.
Yep.
Do we have a tutorial tomorrow, or does it start from next week?
No, we have tutorials this week. Yeah.
Okay, thank you.
So
why do you use parentheses when you use printf format when you're writing the cache register program?
oh, you don't have to. Print is a statement that you don't need the parentheses around, but you can put them.
Similar to C.
Well, I like to pretend print is just the same as calling any other function, so put parentheses around it. Yeah.
And it just didn't get to recognize Python. It just gave me an error that is not recognized. I did it both.
So, for example, you do something like this,
Yeah.
and then you get some error message like this. Would it be different under PowerShell?
No, Python is not recognized.
Yes. So that basically that means Python is not in your path. And so if you look in the book, there's actually some instructions, some magic
I
to...
actually wrote the command in the book and restarted the computer and restarted the program, but it just didn't work.
Okay, then you should, if it's a laptop, you should bring it in and bring it to one of the TAs, and they can have a look at it.
Thank you. Have a good day.
Yeah.
Is this tutorial today?
There's tutorials this week, so all week.
For the assignment, if at some points you're outputting floating numbers while instead of putting integers, is that okay? If I have like a 5 output instead of 5.0?
Yeah. Well, I think the only place that would come up is in the BMI calculation.
Yeah.
So that's the BMI calculation. I would put it in so that it looks like this. I'm not sure that the TAs won't ding you if it's a bit different.
Alright, sure. I was just wondering where you can get a textual copy of the book.
There's no real easy way. You can buy the PDF and then pay someone to print it. And 30. You don't have to buy a laptop. There's machines in the labs you can use, and there's also there's machines in the labs you can use. If you have a computer at home, you can set that up. The laptop's not necessary. So just use the machines in the student labs if you don't have.
Assignment. Do you have why the Python, why the text?
Yeah, that's
So
right.
I cannot copy the output from the PowerShell. What should I do?
So there's somebody who gave instructions on how to do that on the forum. I think you can do select all, and then if you right-click, that's actually a copy. PowerShell.
No, I tried. It doesn't work.
Okay, then bring your laptop into one of the office hours, and one of the TAs or someone else there will be able to show you how to do it.
Okay.
Yeah. I don't use PowerShell or Windows, so I don't.
Oh, okay, thanks.
Yeah. These people are anxious to start. Yep. Let's just go into the hallway. Yep. So what do you want to do? You want to use that file? Okay. So let's Scrabble where is that file? Okay, so Python, side, desktop. So this is September 09.py. And you should also always use this LSQ new. So it says there's an indentation error on line 3. And that's because Python cares about indentation. So inside a function like this, you have to have everything indented to exactly the same depth. So save that and try again. This not get saved. So one thing that's I'm not used to Macs. There we go. So now it's it seems to have loaded it. Probably works. So one thing to really look out for is the number of the amount of indentation really matters. So when you define a function like this, the way it knows what's inside the function and what's outside is, well, inside the function things will be indented, and as soon as it reaches a line that's not indented anymore, it's considered to be outside the function, and they all have to be indented the same amount. So that's the problem there. And just to load it, it's really you just specify the path to the file. If you don't want to have to do that, if you just want to work on your desktop, just change into your desktop directory. And then of course you don't have to specify the path because it's right there. Okay. Clear? Yeah. Good. Yep. Yep.
Wait, when do we have to have this assignment done, right?
It's Monday morning by 8 a.m.
And you just want us to email it?
No, you submit it, we'll receive it.
I'm still in the middle of command line password.
Yep.
This week, like I spelled it earlier.
So I mean, you don't have to go through the whole thing. Just do it enough. I mean, you can do it at your leisure as long as you know enough to do what you need to do. I mean, the usual way to learn the command line is you use it for a while and you pick up some.
So I was wondering if at some point it's going to tell me how to make a pathway to Python.
How to make it? Well, the command line crash course won't, but the book does talk about dealing with files and directories in Python.
Oh, so like x0.
No, it'll be a bit later. So file I/O, you wait a little later to show it because, I mean, that includes the ability to remove, delete files, and you want to know what you're doing. Yeah.
Well, I'm not having is I haven't been able to open like any of the applications in the class. And I mean, it's like .py.
Okay, so there's nothing special that you need to do for that. I mean, nothing special in Python that you need to do. You just run Python with the path of the file as an argument. Just like I could run on the box. Minus I just tells Python to go into interactive mode once it's done loading the files you specify. So just do, well, I mean, get one of those files, make sure that it's in the same directory that you're in, and just do Python -i and then the file name, and that'll load the file and it'll interact with
It
them.
has to be the same directory as my Python.
It either has to be in the same, well, I mean, no, it doesn't have to be in the same directory as you. It has to be the directory that you're in the terminal. So when you're using a terminal, you're always, there's some directory called the current working directory. It's usually displayed, the name of it is shown as part of the prompt, and you want the files to be in that directory. So you can change the directory or you can change the location of the files, either one. There you go. Thanks.
Yeah.